Hi everyone. We are starting a new lesson this week, or in this video I guess we're starting it. It is lesson 21 and we're only going to lesson 27. So our books are done at lesson 27. So that's awesome, we're getting close. This lesson is all about adding and subtracting mixed numbers. So mixed numbers are just another type of fraction. So we're still working with fractions, still working on just adding and subtracting them, but mixed numbers, in the family letter on this page, it kind of explains, it gives like a little brief mini lesson about what we're doing this week, so it's kind of helpful. But a mixed number is just a number with a whole number part and a fractional part. So a mixed number is like 1 and 2/6. So there's one whole and 2/6. So if you're adding that mixed number to this mixed number, 1 and 5/6, they show you kind of with models how to do it right here. But as we go through the lesson in the next couple of videos, you'll see that adding mixed numbers is just as easy as adding basic fractions. Okay, because all you do is first you add the whole numbers. Okay, so the whole numbers are this 1 and that 1. So 1 plus 1 is 2. And then you add the fraction part. So 2/6 plus 5/6. Well, I know I keep my denominator the same, so it's going to be 6. And then I add my numerators, so 2 plus 5 equals 7. Okay, so 2 and 7/6, but there's something wrong with this. So you should notice right off the bat, well, there's an issue because my numerator is it's greater than my denominator. 7/6, there's one whole hiding in there, okay, because 6/6 is one whole. So really, that answer, I have to take 6/6 out of here. So I'm taking away 6, and that becomes one whole. So I'm taking out 6/6 because that equals 1. Okay, sorry if this is really tiny. I'll try and zoom in. 6/6 equals 1. So I'm adding that one whole to my whole numbers. So really that becomes 3. And then if I take away 6/6 from the 7/6, I'm left with 1/6. So my answer's 3 and 1/6. That one's a little complicated because there was a whole number hiding in your fractional part, so we had to transfer that whole number to become 3 instead of 2. So it's kind of like regrouping when you're adding, regrouping a little fractional part into a whole number, but we'll get into it. We'll get there. So if you want to read through this family letter with your parents this week or siblings, whoever you're working with, whoever you want to show your math work to, on the back is an activity, kind of cool. You do like make a little frame and a picture. So you can do that activity if you'd like to. And then our lesson really begins on page 441. Okay. So we are on session 1 of lesson 21, so the first day. So it says previously you learned about adding and subtracting fractions. In this lesson you will learn about adding and subtracting whole numbers and fractions. So whole numbers like 4 and fractions like half. So a mixed number is like that. Use what you know to try and solve the problem below. So this problem, it's not on the page, sorry. It's not mixed numbers. So this is just like what we've been doing. This is just adding and subtracting fractions, or just adding fractions really. There's no mixed numbers. So this is just a regular problem that we know how to do. We did this kind of problem in the last lesson, okay? So let's read it. It says, Raquel measures milk with a half-cup measuring cup, like this one. She fills the cup 5 times and pours each half cup of milk into a bowl. How much milk does Raquel pour into the bowl? Okay, well, I could draw a picture, right? So here's my model. If it's a half, 1/2, I have 2 equal parts. I shade in 1. Okay, so that shaded part represents the milk, okay? And she fills that cup 5 times and pours it all into a bowl. So there's 1 time. I'll draw it again for the 2nd time. There's another half cup. And again, another half cup. And again, half cup. So that's 1, 2, 3, 4 times. She fills that measuring cup up 5 times, it said. Okay. So if she pours all that milk, all 5 of those, into a bowl, how much milk total will that be? So we're just adding 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2 equals blank. So how much total milk would that be? Okay, so I know I keep my denominator the same, so it's going to be halves. 2 is my denominator. And I just add my numerators. 1 plus 1 plus 1 plus 1 plus 1 is 5. Okay, so you could show that with an equation, with a model, maybe you did a number line, however you want to show it, that's fine. But my answer is that Raquel pours 5/2 cups of milk into the bowl. Okay, so again, 5/2 is going to be more than 1 whole cup, right? There's multiple whole numbers hiding in there. Okay, so 5/2. So if I want to figure out what kind of mixed number that is, like what is that in a mixed number, because that answer's fine, but there's whole numbers hiding in there because my numerator is larger than my denominator. So if I draw my models, I'm just going to draw a few of them, and I'm cutting them all in halves because my denominator is 2, so I'm cutting them all into 2 equal parts. Okay, so I want to show 5/2, right? Okay, my denominator is 2, so I'm set. I need to color in 5 of them, 5 pieces. 1, 2, 3, 4, 5. Okay, so 5/2 really equals 2 wholes. 2 is my whole number, and then what's the fractional part? So I got the 2, and then there's 1/2 left over. Didn't need these models. Those are extras. So 5/2 equals 2 1/2. And you can figure that out just by dividing also. 5 divided by 2. So 2 goes into 5 2 times with 1 as your remainder. So it's kind of like a mini division problem too. 5 divided by 2. 2 goes into 5 twice with a remainder 1. And my denominator stays the same. Okay, so this could have been your answer, or this could have been your answer. Either way, that's our first problem. So let's turn the page and answer some questions about it on the back. Okay, so, yep, number 1. Explain how you found the total amount of milk Raquel pours into the bowl. So we added 1/2 5 times. Added 1/2 5 times. If you drew a model or did a number line, you can describe that. Added 1/2 5 times and got a sum of 5/2. Okay, done. Number 2, look ahead. All right, so kind of a new problem. Suppose Raquel has another bowl with 2 3/4 cups of milk. So that's 2 whole cups of milk and 3/4 cups also. She then pours 1 3/4 cups of milk into this bowl. How much milk is in the bowl now? So she had, let's use some different colors. she had this much milk, and we're adding this much to it, okay? So the numbers 2 3/4 and 1 3/4 are mixed numbers. Mixed numbers have a whole number part and a fractional part. So whole number, fraction, whole number, fraction. You can think of 2 3/4 as 2 plus 3/4. You can break apart numbers to add 2 3/4 and 1 3/4 in different ways. Okay, so that's a lot of reading, a lot of words. Let's break it down. So how can you decompose 2 3/4? So they kind of showed us that already. It's 2 plus 3/4. So 2 wholes plus 3/4. Okay, you add those together and get 2 3/4. How can you decompose 1 3/4? Well, same thing, 1 whole plus 3/4, the whole number plus the fractional part. Write an addition equation to decompose 3/4. So how can we break apart 3/4? And this doesn't really have to do much with our problem, but we know how to decompose fractions. We can do 1/4 plus 1/4 plus 1/4. That works. Right? Because my numerators add up to my sum numerator and my denominators all stay the same. Okay, so what are 2 different ways you can add 2 3/4 and 1 3/4? Okay, so like I said on the family letter thing, you add the whole numbers, so 2 plus 1, and then I'm going to add my fraction parts, 3/4 and 3/4. See, 2 plus 1, and then 3/4 plus 3/4. Okay. So, if I wanted to solve that, I add my whole numbers. 2 plus 1 equals 3. And then my fractional parts. So I did the 2 plus the 1 already. So now I'm just working with the 3/4 plus 3/4. So 4 is my denominator still. Denominator stays the same. 3 plus 3 equals 6. So my answer is 3 6/4, but 6 is bigger than 4, so there's a whole number hiding in here. If I take 4/4 out of that and give it to the whole numbers, then my whole numbers would be 4. So I'm taking out 4/4 out of here because there's a whole number hiding. I give it to the 3. So I'm regrouping the whole number to the 3 and making it into 4. So if I take away that whole number, if I take away 4/4 from that, I'm left with 2/4, because 6 minus 4 is 2. Okay. And then another way you could do it is just whole numbers again. And then they want you to, for the second way, I mean, this is probably what you're going to do, but you could use the decomposed way for 3/4. So you could add up, instead of just saying 3/4 easily, you could do 1/4 plus 1/4 plus 1/4, because all that equals 3/4. But that's just for one of those. I still have to add another 3/4, so I'm going to do that again. 1/4 plus 1/4 plus 1/4. Okay, again, that's all right there. So shorter, faster to do it like that, right? But if you wanted to. And you'll still end up with the same answer, 4 2/4. Okay, so number 3, reflect. How does decomposing numbers help you add mixed numbers? So how do we break apart numbers to help us add mixed numbers like this? Okay, so you can decompose mixed numbers into whole numbers and fractions, and then add just the whole numbers and add just the fractions. So copy what I'm writing, I guess, or if you want to come up with your own answer, you can. You can decompose numbers into whole numbers. Oh, I meant you can decompose mixed numbers, right? I just said decompose numbers. Mixed numbers. You can decompose mixed numbers into whole numbers and fractional parts, and then add. Okay, so that's all we're doing. You decompose a mixed number into whole numbers and fractional parts, and then you add them. So pause if you need to catch up on the writing part there, because I'm moving over to practice pages. Zoom out a little bit so the whole page is in the screen. Okay, so in our little bubble map chart over here in the middle we have mixed number. So what is a mixed number? In my own words, how can I explain that? If you want to explain it your own way, go for it. Or you can say what I'm going to say. It is a number with a whole number and a fraction. Okay, and an example is like 2 1/3, because there's my whole number, there's my fraction. Or 1 3/4, whole number, fraction. Or 3 5/8. Okay, so you can come up with any examples you want, as long as there's a whole number and a fraction. What are some non-examples? How about just half? That is not a mixed number because there's no whole number. What about just 4? Okay, that one's missing the fractional part, so that's not an example either. 6/8. Not a mixed number. That is a non-example. That's a bad example because there's no whole number. Okay, so it's not a mixed number. None of these are. And illustrations. So if we wanted to draw what a mixed number is, maybe we want to draw 2 3/4. Okay, so I need to draw some models with 4 equal parts. But I need a few of them because I need to color in 2 whole ones and then 3/4 of another one. Okay, so 2 whole models. Color in the entire thing. That's 1 whole. There's another whole. So there's the 2. And then the 3/4, I'm just going to color in yellow. I don't know if you guys can see that very well. It doesn't show up maybe. Just 3 pieces. Okay, so 2 3/4 looks like this. 2 holes, 3/4 of another one, but not an entire one. It's not 1 whole yet. 4/4 would be 1 more whole. Okay, so there's my chart. Move on to the questions. Number 2. Is 1 2/5 a mixed number? Explain. So is that a mixed number? Yeah, it has a whole number and a fractional part. Yes, but we have to explain. It has a whole number, and I'm going to put 1 in parentheses because the whole number there is 1. And a fraction, and the fraction is 2/5 for that one. Okay, that's my explanation. How can you decompose 1 2/5? So how can we split apart, break apart 1 2/5? 1 plus 2/5. Ta-da! Okay, next page. Okay, we got one problem on the back to do. So number 3, solve the problem, show your work. Don't forget on the bottom, it's the check your answer part. So we'll see what we got to do there. All right, zoom in a bit. Paco measures water with a 1/4 cup measuring cup. He fills the cup 7 times and pours each quarter cup, 1/4 of a cup, of water into a bowl. How much water does Paco pour into the bowl? Okay, so I could draw a model, I could do a number line, I could just do an equation, but remember you have to check your answer down here on number 4, so I think I'll draw a model up here to solve the problem, and then I'll do addition down here to check my answer, okay? So, a quarter cup, I'm gonna draw a model that is fourths because my denominator is 4, so 4 equal parts, but it's just a 1/4 cup, so there's only 1/4 of the model, 1/4 of the cup that's filled with water. Okay, so 1/4. He fills that cup 7 times and pours it into a bowl. So I need 7 of these same models. It's not going to be pretty because I'm not taking my time, but it's going to be fine. Not an artist. 1/4. There's 3. I need 4 more. 1/4. 1/4. 1/4. 1, 2, 3, 4, 5, 6. One more. Ta-da! Okay, 7 identical models. Because he fills it 7 times. So how much water is that? Well, there are 7 of them, and they are fourths. 7/4. So Paco pours 7/4 cups of water, and I could use addition to check my answer. So I could say 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4, 1, 2, 3, 4, 5, 6, plus 1/4 equals, denominator stays the same, numerators, 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, use your fingers, is 7. Okay, check my answer. But as a smart 4th grader, I know that that is fine as an answer, right? That is the correct answer, but there's a whole number hiding in there because 7 is greater than 4. So how many times can 4 go into 7 without being too many? So 7 divided by 4. So it's just 1. So I'm taking 4/4 out of there because there's one whole number. My denominator stays 4. If I take 4/4 out of there and make that my one whole, how many do I have left? So 7 minus 4, or 7/4 minus 4/4, the one whole that I took away would be 3/4. Okay, so 7/4 equals 1 3/4. In 3rd grade, you guys should have worked with mixed numbers, like converting an improper fraction into a mixed number and back, and how to do that. So hopefully this is just a bit of review from 3rd grade and you're familiar with how to do that. But if not, we'll work on it throughout this whole lesson. Okay, that's the entire thing. That's session 1. See you next video for session 2.